Okay, we see several graphs here. Now these graphs, in the longer video, I just drew the graphs, just the shapes of the graphs, and then I imposed the stuff in red on that as I explained it. But you understand that if you recognize the shapes of these as labeled here, they were unlabeled, we went through and figured out what the shapes were, but we should recognize all these shapes, and we should then be able to tell what the graph is. So, for an exponential graph, the one thing you can always at least estimate is the position of the horizontal asymptote. And for a logarithmic function, the position of the vertical asymptote. If the function is the exponential, then f of x would be exponential, and your general shape of your general graph would be a f of x minus h plus k. You would know h for the logarithmic, or you would know k for the exponential. And then you would have to do some other stuff to figure out what the other two parameters, the parameters being a, h, and k, what those parameters would be. In all the other cases, you are able to easily identify and make a decent estimate of h and k if you have enough of the graph. Okay, so for a quadratic, hk would be at the vertex. Because why? Because h and k are your horizontal and vertical shifts. So if you have a quadratic, your basic quadratic at vertex at the origin, if you shifted horizontally h units and vertically k units, the origin translates to the position h and then the position hk. Okay, so the vertex is the point hk, so that we could then pick any other point on the graph, estimate its coordinates, and use that to evaluate A. Okay, so in the quadratic, your HK point is the vertex. For cubic, your HK point is the point where the thing just totally flattens out for an instant before going up. That would be the origin for the basic function. For the general exponent, or for the general cubic function, it'll be the point HK. And again, you'd have to figure out the vertical shift with another point. For the square root function, graph looks like this. Here's the zero of the basic function. This would also be the point hk then, if the function's in this form. Cube root function, reciprocal, or the absolute value function, same thing. You can easily identify the hk point. The reciprocal and reciprocal square functions, if you have enough of them, you can see where the vertical and horizontal asymptotes are. The vertical and horizontal asymptotes in both of these are the x and the y-axis for the basic function. So the point where the two asymptotes cross is the hk point in each case. And again, we have the information we need to get everything but the value of a, which can always then be estimated by estimating the coordinates of some other point in solving a simple equation.